We're still talking about the pizza dough here for question 4.3. This pizza dough is being tossed up, but now 4.3 is asking us to write an expression for the rate of change of the height of the dough with respect to the radius of the dough in terms of height h and radius r. This one's a little trickier. The reason for that is because this is not the rate of change of the dough with respect to time. This is not dh dt. Instead, if we read the question closely, write an expression for the rate of change of the height of dough, so that's going to be dh over, with respect to the radius of the dough, that's dr. dhr, we haven't seen this type of thing before, and so we're going to try to have to manipulate this a little bit. We're going to start off with a formula that we know that uses h and r in terms of r being radius, and also relates those two things together. And the formula we know is the volume formula for the cylinder. Volume equals pi r squared h. Now, in order to get to anything, d something, we have to do some derivatives. So let's find the derivatives of all of these with respect to time. I'm going to use a different color here. That's going to give us dv dt equals pi times, and again, I'm taking the pi out because it's a constant when I'm finding this derivative. I see two things being multiplied, r squared and h, and so I'm going to use the product rule. First, find the derivative of the first part, so that's 2r dr dt. Keep the second the same, and then keep the first the same and find the derivative of the second, which is dh dt. Now, I'm going to distribute that pi and do some rearranging, so I get dv dt equals 2 pi rh dr dt plus pi r squared dh dt. Alrighty. Now, what do? Well, I want to get dh dr, but I don't see that yet. First, let's get rid of something that I know I can get rid of, which is this dv dt. Why? Well, the question tells us that we have a constant volume of pizza dough. So that means if the volume is constant, dv dt is 0, because if it's constant, it's not changing. There's no rate of change of the volume. And so I'm going to replace this with a 0. Now our goal again is to get dh dr, and let me talk about how we would do that. I'm going to do this in yellow on the left over here. dh dr. Now dh dr, the way to do that is we have dh dt, and we want to divide that by dr dt. And you might be like, what, Mr. Null? Like, why would we do that? Here's why. As you remember, when we have these two things, if we divide two fractions, it's the same as multiplying by the reciprocal. dh over dt times dt over dr. These dt's will get rid of each other as we multiply them out, and so we're left with dh over dr, which is what we wanted. With that thinking in mind, let's do some manipulation of this so we can divide dh dt by dr dt. So let's bring this back over here. This idea, we're holding that idea in our head. In order to do that, I am going to move this 2 pi rh dr dt to the left side. And to do that, I'm going to have to subtract it. So we get negative 2 pi rh dr dt equals pi r squared dh dt. Now we want to get that dr dt by itself, or so we want that dh dt by itself first, and so I'm going to divide both sides by pi r squared. So divide by pi r squared, divide by pi r squared. I know those parts will cancel, and so I'm going to be left with negative 2 pi rh dh dt over pi r squared. These pi's will cancel, right? Because they're going to divide each other out. Pi divided by pi is 1. Oh, no, I should write. This equals, that's dr dt equals dh dt. This r and one of these r's will get rid of each other, and so I'm going to rewrite this just a little neater. Negative 2h over r times dr dt equals dh dt. Now our final step is to get this situation, over here on the left, you'll see me boxing this in, dh over dt over dr over dt. How do I do that? Well, I'm just going to divide both sides by dr over dt. If I do that here, since I see the same thing on the numerator and denominator, those will cancel. And I'll be left with negative 2h over r equals dh over dt over dr over dt, we already showed. That's dh over dr. And so here we are. An expression to relate the rate of change of height with respect to the rate of change of the radius is negative 2h over r. Little tricky, not just little. Might take a little bit of time to watch this again, see where everything goes, ask some questions, but this is a good type of question to see. Am I noticing these different relationships? What do I need to do to get there?